This lesson is about no filter set at all in our tube. This is a third setup that we can use for increase the reading of some specific elements. This method is useful for these elements over here, basically starting from silicon 1.7. This method enhances the reading of these very low energies. We basically we consider the range from 2 keV down to sodium. We know that we can't read it, so to magnesium. Just to recap, remember we have this one is the routine filter set, so it means it's good for all when we have to analyze our object, so we don't know what's in there, so we just want to have a preliminary view of the object. So we use this setup where we are using these two filters on the tube with this specific kilovolts and microampere. Then we saw in a previous lesson that when we want to focus on lines, XRF lines below 10 keV, this setup is better. So in this case we want to use just one filter, aluminum filter 0.25. And so this one was discussed already. In this class we introduce the no filter set. We don't add any filter to the tube at all. We change now the kilovolts, now it's just 10 and the microampere is 10. No filter, the usual 30 seconds, because we want to keep the examination relatively fast. I prepared the experiment, so this is our XRF system. Under the system there is HDPE, high density polyethylene. It's over here. This one, remember, this material acts as a mirror for the X-ray, so we have an idea of the output of the tube. And we did the examination basically using this tube output, the standard one, so just the tube at 50-50 without any filter, and this one, the new one we are discussing, to enhance peaks less than 2.5 keV, that is using kilovolts 10, microampere 10 and no filter at all. Let's see the results. The red one is the spectrum of the tube without any filter and with 50 kilovolts and 50 microampere. The black one is now the spectrum of the tube without any filter, but with 10 kilovolts and 10 microampere. Since now we have for the black one, for this curve, 10 kilovolts, so the voltage of the tube, of course we don't have all these X-rays over here. What I want you to focus is on this area over here. So you see, from 2.5 keV to 0, this area is pretty flat. It is an area that has not peaks overwhelming it. This is the area that actually we can use pretty well to analyze the elements and the lines that are in this area, lower than 2.5. The element which will benefit to use this approach will be those starting from magnesium until silicon sulfur. Let's do the experiment. So we put the pigment checker under our XRF system and we analyze green earth. Green earth is a mixture of minerals, mainly is celadonite and glauconite, which are iron-rich silicate minerals. There is silicon. The red one is the green earth spectrum, done with the low-KEV filter set. We just put into the tube one aluminum filter 0.25 that we know is good to enhance those peaks below about 10 keV. We see a lot of iron, of course, it's over here, but we don't see any silicon. So silicon is supposed to be over here at 1.7. Then we do the experiment, we remove the filter and we use the no filter set 10 kilovolts and 10 microampere. In this case, you see the spectrum now changes, and here we have the peak of silicon 1.7. This area we can't use it over 2.5 because there are a lot of peaks that comes from the tubes itself. This area, of course, it's not of interest for this measurement. We just cover from here from 2.5 until, let's say, 0. And here we have the peak of silicon. So using this approach, we can confirm the presence of silicon in our spectrum.